All right, proportionality theorem. So we're going to finish up this section on similar triangles with proportionality theorems and triangles. If a triangle is, or if a line, parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. All right, so really, if we have a picture of that, excuse my writing there, you have a picture of that. Let's say we have triangle A, B, C. We have a line that breaks somewhere in the triangle that is parallel to one side of the triangle. Okay, so if that's the case, in this particular situation, our if-then statements say then if AC is parallel to DE, then what we have is BD is to AD as, so this piece right here is to this piece right here as CE is to BE. Okay? All right. And I guess I've kind of got those flipped around here. So this should actually read BE is to CE. Okay? So you're looking at it, you've got to think kind of this short side right here matches up with this short side right here. So AD and CE. AD and CE. And then this longer piece, DB and EB, those match up right here. All right. So that's one of them. The converse of that is also true. Oh, one other thing. Also, we also know the inverse is true. So if AC is parallel to DE, then BD is to AD as BE is to CE. Okay. Then we also know that if BD to AD is not proportional to BE over CE, then we know that the two sides would not be parallel. So AC would not be parallel to DE. So if the two sides are parallel, then you have this proportionality situation. If the two sides are not proportional, then those sides, or if your pieces are not proportional, then your two sides are not going to be parallel. It'll make a little more sense as we start practicing some of these. The next piece, we talk about the converse of this original statement. So if a line divides two sides of a triangle proportionally, then it is parallel. That line is parallel to the third side. Okay, so once again, if we have A, B, and C, and we know that we have this line here, DE, this segment, dividing the triangle proportionally. In other words, AD would be to DB as CE would be to BE, or EB, I guess, the way I have it written up here. Okay, so AD is to DB as CE is to EB. If that's true, then AC would have to be parallel to DE. Okay? Very good. The counterpositive is also true, which just states, hey, if those lines are not parallel, okay, they're not parallel, then your sides, AD over DB, would not be proportional to CE over EB. Okay. So kind of a whole bunch of stuff saying really the same thing here. Okay. One thing that gets confusing in this lesson is knowing how the fractions lay out. So let me kind of show you that really quick. If you were to envision this as a big fraction bar kind of right here, really what we're saying is this piece right here this piece right here over this piece is equal to, think of a big equal sign here, and then this piece over this piece. Okay, so that's kind of, think of this line right here as your big fraction bar. All right, and really that's all you've got. You've got your proportionality statement. I'll show you that when we actually do some examples. Okay, so let me erase some of this to kind of clean it up just a bit. All right, and we'll put our DE back in there. Okay, so let's try some examples here. So what's the length of CE here? So I'm looking at this picture. I have parallel lines, so I have a line parallel to one side of my triangle. So I know that that divides the triangle pieces that it cuts out proportionally. In other words, DE intersects the other two sides of the triangle right there. So I'm going to trace DE. And notice I've traced it past the actual end of the triangle, because what I'm trying to do is I'm trying to create these proportions. 8 is to 20 as 18 is to x. And really that's as simple as it goes. That line right there, that parallel line, will just create that proportion you need. Okay? And then we cross multiply. 8 times x, 8x. That 8 is kind of an ugly one, so let's fix that. Equals 20 times 8, also known as 360 degree, or 360, excuse me. 8 divided by, or 360 divided by 8 is 45. So x would have to be 45. So this would be 45. The same is true over here. Determine whether AC is parallel to DE. Well, if this is parallel to this, that would mean this line right here would divide these pieces proportionally. You could set up a proportion. So if it's true, either 46 over 24 or 24 over 46 would have to equal, 24 is on top, so 32, the one right across from it would be on top, over 60. That's your proportionality. And one way to figure out if it's proportional is either to reduce both fractions or cross multiply and see if you get the same value. I'm going to reduce the fractions. I think it's always good to work on that. So if you have a hard time with it, just keep cutting in half if you can. So 24 breaks down to 12, 46 breaks down to 40 or 23. And really, I can't cut it in half anymore, so I'm done with that. 32 breaks down to 16. And 60 breaks down to 30. Well, we cut that in half again to 8 and 15. All right, well, nothing goes into 8 and 15, nothing goes into 12 and 23. So really, this statement says 12 23rds is equal to 8 15ths. And I know that is not true. Therefore, is AC parallel to DE? AC is not parallel to DE because 12 to 23 is not equal to 8 over 15. All right. Let's take a look at another one, three parallel lines theorem. So now we have three parallel lines. In this case, line G, line T, and line S. Those are parallel. If three parallel lines intersect two transversals, so in this case the transversals are E and N, the three parallel lines, let's write those, that would be G, T, and S as marked there. Okay, so if they intersect two transversals, then they divide the transversals proportionally. All right, so in other words, once again, this becomes a fraction bar. Now it can get more complex with the problems, but just kind of the foundation, this right here could be a big fraction bar. I know it's a parallel line, but if you look at your middle parallel line, think of it as a fraction bar. What this is saying is this length, or OP, is to PQ as NS is to SR. So once again, here's your big fraction bar, if you think of it that way. Okay? That becomes your proportion. So note what has to happen. Three parallel lines cut by two, intersecting two transversals. Let's try some here. So I look at these diagrams. Notice I have three parallel lines. I have them intersecting transversals. So this middle parallel line can become my fraction bar. So I have x over 28 is equal to 8 over 16. That's just cross multiplying. 16x equals 28 times 8. It would be a lot easier if I would have reduced 8/16 first to 1/2, but that's okay. Okay, and divide by 16 there, and I get x is 14. All right. Well, same thing here. Notice three parallel lines. The middle one can become my fraction bar. Okay, so I have 6 over 5 is equal to 12 over x minus 1. I hope that you're pausing every once in a while and trying these on your own. Cross multiplying, 60 equals, or this is 6 times x minus 1 in a quantity form. So I'm going to divide by 6 on both sides to get x minus 1 equals 10. Add 1, x is equal to 11. You could have distributed. I just chose to divide out the 6 because it's 6 times this whole quantity here. And the last one, well, it's important to note three parallel lines. There's kind of the fraction bar if you think of it that way. 4, we don't know what this is, but we can calculate it. 10 minus 4 gives us this length, which is 6. Okay, so I have 2x over 9, or 2x minus 10 over 9 is equal to 4 over 6. And like I said earlier, you could reduce. 4/6 becomes 2/3. Just makes the numbers a little easier to deal with. So when I cross multiply now, I have 3 times 2x minus 10. And I have 9 times 2, or 18. Could divide out that 3, so I get 2x minus 10 is equal to 6. Add 10, so I get 2x equals 16. Divide by 2, x is equal to 8. It's always helpful if you state the steps if you're not listing those intermediate pieces. To state them makes it a little easier so you don't make mistakes. And then remember, you can always test your answers. Plug x back in and see if it actually truly gives you a proportional side. We know this is 2/3. So if I put 8 in, that's 16 minus 10, or 6. 6/9 is also 2/3. All right. Well, one last one. If a ray, so let's say this is my ray here. Realized after I drew this, kind of cut off the ray. So there's a ray, okay? If a ray bisects, notice it's bisecting this angle, an angle of a triangle. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Okay, so really what this is saying, it's saying that this ray bisects these angles. So it cuts this side at the end of the ray on the triangle. So BD is to DC as BA, this one, is to this one. Okay, so we have BA is to AC. All right, now you'll notice something here. This line right here, you can almost think of that as your fraction bar, right? So this over this equals this over this. Really, that's what it's saying there. So as I'm trying these problems, notice I have my angle bisector. So if I kind of think of that angle bisector as my fraction bar, I have 30 over x, right, is equal to 15 over, well, this is 21. Cross multiply there, 30 times, well, you know what, actually, let's reduce first, right? Let's go ahead and change this to 5 and 7. So it gives me 30 times 7, or 210, is equal to 5x. 10 by 5, and I get x is equal to 42. Sorry for my dogs in the background interrupting there. All right. Let's go ahead and do one more piece here, and note this picture. Okay, we have 10, and this whole length is 24. This has to be 14. And if I think of this once again as a fraction bar, I have 10 is to 14 as 2x minus 5 is to 21. And I once again can cross multiply. But I might want to reduce first. Let's go ahead and take a 2 out of this. So that becomes 5/7. Just makes the numbers easier. So 21 times 5, or 105. And 7 times 2x minus 5. Okay. And I can divide 105 by 7. 7 goes into 10, looks like, 1 and 5 is equal to 2x minus 5. Add 5 over, I get 20 equals 2x. So divide by 2, I get x equals 10. I scrunched myself there at the end. Let's slide this over here. So x equals 10. And remember, you can always check it. 2 times 10, well, that's 20 minus 5 is 15. So 10 over 14 equals 15 over 21. Well, 10 14ths reduces to 5/7. 15 over 21, well, 3 goes into 15, 5, and 21. 3 goes into 21 7 times. So 5/7 equals 5/7. So it checks out. That's all I got for you. Good luck.